on, sorry about that, testing your experiences with a screen reader by Joey Lee. And then I'll go through a second part of what we did last month on setting up a React application, with this second step being the CSS integration to it. But let's just give everyone a few more minutes to jump on board. And while we do that, Joey, do you want to just give a brief intro about yourself, about where you're working at, your developer experience, favorite stars?
Yeah, I mean, there's just so many. Oh, we're gonna need more than an hour to cover them all. But yeah, so I'm Joey. I work with Aiden, who is another frequent talker at these meetups. It's Homeward, which is sort of a real estate startup based out of Austin. And I work as a senior front-end engineer. Just joined the company for almost 5 months ago, but prior to that, I was working at Amazon as a front-end engineer up in Seattle. And then prior to that, I was working for a healthcare insurance company based out of Florida.
So what got you into like screen reading testings? Is it just something that you specialize in, or is it just something that's just part of your tool chest?
Yeah, so when I was working for a health insurer out of Florida, health insurance is got lots of legal stuff involved with it, but basically it kind of boiled down to that due to it having to kind of conform with a lot of legal obligations. One of the legal obligations was that your websites, all of your software and stuff needs to conform to government accessibility standards. Like those are commonly referred to as Section 508. And so, yeah, just learned basically working there, doing UI development and developing like health care enrollment applications, what screen readers were, what accessibility was, why it all mattered, how to do it, different things related to that. And then that ended up getting me a job at Amazon, working in their retail organization, trying to make the shopping experience of Amazon.com more accessible for customers with disabilities.
Wow, so you're almost like a specialist.
I've got some knowledge, but there are definitely more knowledgeable people in the industry. But hope to share what I know.
Yeah, thanks for coming today and presenting what your knowledge is, because I think this is, I know like Aiden has given talks about it, but I think it's super important. I worked in education, super important. I used to work in fintech, super important. It's like, it's one of those chores that developers don't like to do, but it's super important. Like you just got to do it, you know? And so as if we give more presentations, we get the word out, we just make it a normal part of the job kind of thing, the adoption will be great.
Yeah.
And I think you and I are doing a great service to us, everyone here. So appreciate it.
Yeah, for sure.
So what's I know it's a random question. Who's your favorite star? And there's many of them. So yeah, just like a little fun question, right? So who is your favorite star? Do you have a favorite star?
I don't know about my top favorite. Well, no, it just came to mind. I was trying to think of the last couple movies I watched. The last one was Cruella, which is like a new Disney movie. It's kind of cool, like origin story of Cruella de Vil. But my favorite star was not in that. My favorite star was in the movie I watched before that, though. Free Guy, Ryan Reynolds.
Oh yeah, Mr. Reynolds.
Yeah, more commonly known for his work in like Deadpool and a bunch of other like various comedies and things.
Yeah, definitely. Do like those Deadpools. His character really matches that cartoon, so, or the comic book character. Awesome. So I guess just welcome everyone back again. So we're going to get started here. But before we do that, what we usually like to do is just go over some tech news, just random tech news that's part of our, I guess, jobs now, that things change so very often within months, within weeks of our learning of a new tool. And web development is such a big field that, and then especially if you are writing JavaScript covers a lot. The ecosystem is huge, from back end or front end, different frameworks and libraries, and these things are always constantly changing. New tooling, new mental models, new paradigms. And so what I like to do is just go through a few kind of like blog posts or links that I found, friends have shared with me. I get messages on the meetup about new tools, which is awesome. And so that's what I'll do now, and just go through quick, maybe like 5 or 6 of those right quick. So let me just share my screen here. All right. So hopefully that screen sharing, you can see my browser. There's nothing wrong on my laptop here. But the first one I want to point out. Oh, thanks, Joey. I think the first tool I want to point out is this React3 Fiber. So I've been doing a lot of just, I guess, just curiosity about rendering, React rendering, and this is kind of motivated by trying to learn about animations on the front end. And I found this awesome Three.js kind of thing where they where a tool where you can use this tool to create like these 3D renderings. And this is kind of where I want to play with, kind of like a playground. I found this library. It's pretty nice. It's React oriented, obviously. Has a nice fresh API. Looks pretty straightforward, and it renders to the canvas. So you get all the power and I guess flexibility associated with that. It's well documented. It has lots of examples, which I love. This is a great way to learn, is by copying other examples, right? So check this out if you're into the 3D rendering, Three.js. And I guess this implements also the new stuff that's coming out with React 18. So check that out. Another thing that popped on the radar this month is associated with JavaScript, right? ECMAScript. And I guess every, ES 2022, what kind of new stuff they're going to be adding to the JavaScript. So if you're not familiar with the TC39, right, it's a group of, I guess, engineers that review the proposals. And this blog post here, and I'll post it in the chat soon, goes through what's been included since ES 2016. ES 2017, you can see the async await function, which is awesome. 2018, 2019, wow, 2021, and then what's coming up next, right? And so what are the new tools that are coming into the ES 2022? So check that out if you are trying to stay on top of the latest. I guess if you're using Babel, and you're compiling down from the latest and greatest of JavaScript, these are the new methods and tools that you can look forward to for the next round of updates. So check that out, definitely. So as a JavaScript developer, I think, doesn't matter if you're front end or back end, I think it's awesome that this language can be used on both the front and back. There's a couple of little differences associated, working the front end and the back end, but I like to view it as kind of like a universal JavaScript so that you can write the JavaScript you write in the front end and the back end, kind of reusable and whatnot. And you can also grow as a developer, learning the JavaScript in the back end. You can go into learning how the JavaScript behaves in the front end and vice versa. And part of that learning is, learning about staying on top of like security stuff. And so I found this excellent cheat sheet on Node.js security. It's I used to have so many links saved that talks about these kind of security implementations, what to look for, and this kind of cheat sheet kind of sums it up together in a single place. And so if you are trying to expand your security mindset, are you playing with Node.js and you want to learn about the security stuff, this link is amazing. Has pretty much it's maintained by the OWASAP, so it's pretty good. Check it out. Expand your knowledge. Learn about anti-CSRF tokens, so on and so forth, and how to write them, right? How to write it in your JavaScript, in your front end and your back end, so that you can practice like best practices. Another cool React library that I found is React Render Tracker. Now, this is something that I started playing with it just because I'm working on this project, and it kind of gives you an idea of what is rendering in your app. So essentially, if you go down the rabbit hole of your dev tools and you're looking through what is rendering, what is not rendering, how it's rendering, should you use memo, should you use memo, use callback, so on and so forth, this little tool will definitely help you. So I quickly looked at it today and I was like, yes. And that little this little image here with the little counts on it, kind of just does it for me. It's like, yes, I just need to know if I change something, can I see how many times this thing is rendering? And so it kind of tracks that for you. It's very simple. Obviously, if you look at the project, it's not, there's a lot to work, but for the bare bones of what it is, it does a really good job. So check that out. If you're doing some kind of like performance, trying to figure out how or what is rendering, and also just like learning about the React render cycle. How does the parent-child rendering relationship work? How changes in certain state impact all the children, some of the children, or even siblings. So that's really good. And the next one, this one kind of struck home with me. I always struggle with structuring my React applications. And so this blog post, I collect blog posts on how projects are organized with React. React is not does not have an opinion about it. I think even even here, right? Even in their webpage, it says that exactly, right? React.js doesn't have an opinion on how you put your files into folders. Anyway, so this blog post, this gentleman here goes through what he's been doing, and it kind of just struck home with me because this is exactly what I'm struggling with right now. And I've been doing front-end development for quite some time, and every time I got to step back and just think about how should I set up my folders, how should I name my directories, my configurations, my APIs, my services, so on and so forth. And because React does not have an opinion either way, it's very flexible, but at the same time, it's kind of overwhelming, constraining. There's too much freedom. Versus if you use something like more of a heavy duty framework like Angular, the opinion's already set and you kind of follow the best practices there. But again, if you're kind of like in the same predicament that I am, or just want to learn a new way to structure your React applications, check it out. I'll put this in the chat as well. It's really good. It's a long post, but he does a really good job of explaining the why, which is great. And the last one here is a little improvements on CSS modules. Now, CSS modules, we'll be talking about it in the second presentation. But I just want to show that CSS modules has kind of made its way into the browser. And what this I guess piece of news means is that you're able to import these style sheets, right, into your JavaScript. Now we're going to be using PostCSS, and I'm going to show you how to do that in Webpack. But they're actually building this, right? The Microsoft and Google team have collaborated to bring CSS into Chromium, which is pretty incredible. So if you're staying on top of this kind of things and you want to follow like the latest trends of what's coming up in the browsers, this is one of those things that if you're using CSS modules already, then this is probably kind of something on your radar that you probably want to keep an eye on. And you click on this link here, and it takes you how to use it in the style sheets already. So it's kind of impressive that they're adopting into their browser instead of you don't have to use you won't have to use a build process to it like Webpack, but I guess we'll see. Anyway, so that's kind of like the tech news for today. I think with that being said, I think I'm just handing it off to Joey and for the screen reader presentation.
Awesome. Thanks, Roberto. And those were some cool things you shared. Thanks for sharing those. All right, so let me go ahead and share my screen. All right, start up some slides here. Cool. All right, so yeah, my name's Joey Lee. I'm going to talk for a little while about how to usability test your experiences with a screen reader, what all that means, and why you might want to do it. So agenda, I'm going to talk about the problem, some of the different solutions available, who I am and why I think I might be able to help you. What screen readers are, some sample setups, and then a lot of different resources, because this is a deep topic, or rather a topic that can go pretty deep, but we only have so much time tonight to talk about it. Cool. So what is the problem? You want more customers. You want as many customers as you want. It is possible, rather. And with your current customers, you obviously want to get as much depth and sort of market penetration in whatever market you happen to be working in with customers you have. And so just some statistics around kind of the topic of disabilities and assistive technology, accessibility, all of this stuff. According to the CDC, these are the latest figures, 61 million adults in the US live with a disability. One of the more common forms of disability is reading impairments. It said that up to 10% of people in the US, or to give you an idea of what that kind of equates to, basically the entire population of Canada, have difficulties reading. This can either be a result of vision impairment. Maybe they have limited vision. They have to wear glasses to see it all. Maybe even with glasses, they can only see a little bit, or maybe they have total vision impairment. They're blind. But yeah, 10% of the US population has some sort of reading impairment. Obviously, this is a big necessity, or at least it seems like that to most people, in order to navigate the web effectively. Seeing what's on the page, then being able to interact with it, use a mouse, all of these things typically, they do require some usually substantial form of vision in order to accomplish that. But yeah, I mean, this is one big problem in and of itself. And then two, it's actually the law. So For most businesses, yeah, accessibility basically falls under the heading of a 2019 court ruling in the United States, which was that basically all websites need to conform to either Section 508, but that ties back to WCAG, which stands for Web Content Accessibility Guidelines. It's also created by like kind of a similar web governing body, like the TC39 that Roberto mentioned. But yeah, they're basically standards around web accessibility um, that yeah people need to follow. Otherwise, they can very easily get sued. Lawsuits in the space have compounded the past 3 years. It's a rate of 25% year over year. So yeah, a lot going on in the space. So who am I and why do I think I can help you? So I'm a senior front-end engineer at Homeward. You may have seen Aiden give talks, who also works at Homeward in the past. Prior to this role, I was a front-end engineer working at Amazon on their retail accessibility team, where my job was to help build software that was used in running automated accessibility tests. And this was used to scan tens of billions of UI widgets monthly. Basically, what our software was used for was before any new content could ship to Amazon.com, our testing software had to say it's good to go, no issue, no accessibility issues. And so, yeah, important software. And then prior to that, I was working at a health insurer based out of Florida, where I learned a lot of this stuff, building healthcare enrollment applications and things that needed to conform to government standards. So we understand the problems now. What are some possible solutions? So there are businesses that have started to pop up in recent years. Things like that provide sort of kind of software as a solution. Things like overlays, plugins that claim they can kind of solve the problem of accessibility. I don't believe this is true, and it's for some of these statistics, which I'll share. So the industry's best automated testing tool, I worked on a similar tool at Amazon, and yeah, we were probably roughly the same, can detect 57% of issues um, when the software runs, or rather this testing software runs against your software. But even if it can detect 57% of issues, it says nothing of being able to actually fix those automatically, and let alone anywhere near 100%, like a lot of these kind of plug-in and widget and overlay softwares claim to be able to do. So there's really no evidence that they're effective, one. And then two, an interesting statistic too, is that lawsuits against web applications that actually use this software in 2020 by the end of the year reached one a day. So isn't solving the problem, isn't stopping lawsuits against businesses who are using this. So really, the only effective solution, in my opinion, is to try and own accessibility in-house. So owning your accessibility as a company, software developer, so on. So I kind of try and think of this as sort of a flywheel, where you basically use education and awareness to kind of train your staff, learn about the problems, learn about the solutions. In things like React, we try to create React components so that when we have problems, we only need to develop components. Ideally, you solve them once, and then you can kind of keep reusing these components. So you don't have to keep reinventing the wheel, so to speak. There's a bunch of testing solutions, which I'll share. And then, yeah, just kind of refine and keep the wheel going. So yeah, is part of this cycle too. There's a lot of different forms of assistive technology that people with disabilities might use to interact with your software. What I'll be talking about today is screen readers, which is one of the great place to start. One of the most common forms of assistive technology, or AT. And the one I'll be showing as an example today is VoiceOver on Mac. just installed at the operating system level, built into every Mac. You don't have to do anything special to get it. So really nice tool. So yeah, what is assistive technology? What are screen readers? How do they work? Screen readers are a type of assistive technology that, as the name implies, they read what's on the screen while also providing a mechanism for a screen reader user to interact with what they see on the screen. How this all kind of works behind the scenes is screen readers convert your visual application into a non-visual model, which then actually replaces the visual and click-based UI that customers typically, or a large percentage rather of customers typically interact with, pointing around, clicking on buttons, things like that, links, form widgets. Screen readers basically convert all this into a non-visual model, and then through a series of platform UIs that the browser exposes to the software, for instance, VoiceOver, it basically provides kind of a two-way communication mechanism. So that, yeah, even if you can't see what's on the screen, you can't operate a mouse to interact with it, you can use a screen reader to have announced what it is that you're interacting with. And I'll show all examples of all of these things in just a little while. And yeah, just basically by like using a keyboard or some other input mechanism, you can still go about and use the software, cited or unsighted. So really cool and interesting software. Oh yeah, and so kind of the model that the browser organizes your application into and then exposes it to assistive technology such as screen readers is it's in a tree form. We're all probably used to the document object model, and so trees probably aren't too unfamiliar, but here's an example of sort of what the accessibility tree, as it's called, looks like. You basically have different nodes representing all of the elements and content in your application. It boils down ultimately, or rather bottoms out, into either content elements, take for instance paragraphs, or interactive elements, like you've got form inputs, buttons, links, so on and so forth. But yeah, every node in the document object model in your application, every piece of content, every interactive element has a role, and all these things kind of bubble up to form a model of your app, again, non-visual, that can then be interacted with by assistive technology. So we're not going to dive too deep into the setup because it does take a little bit of time, but rather I'll show you how, after you go through and have done the setup, what it looks like to use a screen reader, and then how you could go about doing so. And then all the slides will be available later for reference for those who are interested in going through and setting up VoiceOver on their own machine. But yeah, some common navigation things also that we're not going to dive too deep into. So once you do have sort of this screen reader set up on your machine, some different approaches that you can take and look for to actually test your applications for accessibility really boil down to kind of these 4 principles summarized in the acronym POUR, which are perceivable. Basically, can the content of your application and interactive widgets be recognized in the first place? 2, can they be operated? And as part of that, operated successfully by keyboard only, since again, non-visual users of your application are going to be able to just use a mouse to locate things and click on them. Can they be understood? Is it clear what they're doing, what states they're currently in or can change between? And then, is the software robust? Can it work across devices? Can it work across sizes? screen orientations, things that we're already kind of commonly worried about as front-end developers. And then another tip, because we are using a screen reader, trying to emulate unsighted users or users of assistive technology when testing our software. Try closing your eyes. This is how a lot of users will be interacting with your software if it's publicly available. And so it's good to know that it works, obviously, when trying to develop it and fix things. Cool. So I'm going to walk through a couple examples of what it looks like to use a screen reader, and really just what it's, how they work, all that kind of stuff. Just going to go through some basic examples to start, and then I'll end with a slightly more complicated example. So first one I'm going to start with is just looking at a page with text up front. Looks like nothing complicated. Like you got some headings and some text and paragraphs. It's like, how could this not be accessible, you ask? Well, let's find out. All right. So I'm back here. So the first thing I do when opening this page with a screen reader is open this common navigation mechanism that's either called the elements list or the web rotor, as I talk about the instructions. It's basically it's kind of a shortcut with screen readers so that you can basically organize the page and interact with these different elements by category. So some categories are articles, buttons, links, forms. And as we go through and use the web rotor, we'll see that this particular page, it actually doesn't have any entries in these different categories. So I'm just going to dive in, or rather I just dive in with my screen reader and start interacting with the page. I see my heading. And then as I try to navigate around with a screen reader, it's not really making a lot of sense. Ignore the lorem ipsum actual text, but there's a lot of clunky navigation. There's weird containers, headings aren't labeled or marked up as headings. Yeah, and so if we actually look at the HTML for this website and see, hey, what's the code behind this experience? It's actually not using any semantic markup at all. The first heading, it's not using an H1 or any of the heading elements in the HTML programming language, but it's using a font element, which is strange, using a lot of breaks to create spacing in between your text. That's why navigation was clunky. Yeah, and because no headings in these other semantic elements were used to sort of organize the content of the page, that's why no headings showed up in our web rotor or elements list navigation that we played with. Now, if we contrast this with an example of good semantics, we can see what this looks like by comparison. So first thing I'll do in the page is still opening the web rotor. All right. And so in this basically rewriting of the semantic content provided by MDN in their example. We can see in the web rotor elements list, there are a bunch of headings listed. We'll see why in the code that is in just a second, but super useful for navigation, easy to go around, find what you're looking for as an unsighted user. But then even just diving into the content and manually kind of going back and forth through it on the page. Navigation isn't clunky, very smooth, makes sense. You can use headings to get kind of a lay of the land, understand where you are, what you're reading about, what you're interacting with, so on and so forth. So going to dive in just a couple more examples here. Oh, and then also let's look at the code for that good semantic content. Quickly see, oh, that's not the one I want. Good MDN, good content semantics. Oh, my link is broken. All right, it's not there. All right, so just quickly explaining. Basically, the reason why this content navigated so much better than the first example is because there are semantic elements used. HTML is a semantic language. And what that means is that elements have a specific purpose. These HTML like tags and elements that you use and put content and interactions in they all have specific purposes. One of the reasons being so that assistive technology can interact with it in a way that is understandable. And yeah, so how this was coded is basically headings were marked up in heading elements. So top one was an H1 element, kind of like folder structures. You start at one, work down. That's top of the page. Then you've got a bunch of paragraph elements, another semantic element used to deposit content into. You've got some more heading elements. These are probably H2s for the other respective headings, and then more paragraph elements, but provides really, really nice navigation. So let's look at a couple other atomic examples real quick before moving on to something a little bit more complex. So this is links, bad links specifically. So start with the web rotor or elements list navigation. And the first thing we notice is there's a bunch of click here links. We'll look at why that is in a second. Headings are marked up nice. Those show up good. But then when actually interacting with links on the page, they just say, click here. There's no context, where they go, why you would want to click them. So the reason for that is because they are literally just links that, irrespective of where they go, their only label is click here. So if we contrast that with an accessible example, let's see how this navigates by comparison. Open up the web rotor. And first thing we notice is we've got a bunch of links again, but these have much more accessible labels. Great context. We can see what the links presumably go to. So really great, clean, context-driven navigation. And then diving into the code real quick, just to see what these entail. So still links on the page, but basically the labels or text inside of the anchor tags in the HTML, they just capture context and information that your users would probably need to be able to decide whether or not they want to click on them versus just click here, for instance. Cool. I'm going to dive into one more set of atomic examples real quick, and then we'll move on to a more complex example. So in the web rotor, under form controls, really under anything, there's no entries. So when navigating the page with a screen reader, we see a heading, it says bad form. And then we see some text that says enter your name. But then we land on an empty input field. It's not clear what it's for. If filling out this form the only information you would have to basically go off of is like what sort of label or just random text came before this when deciding what to fill it out, if to fill it out. But yeah, basically have no information like what's desired of the form input. And that's because, well, an input element was used. It's not written. There's no what's called a programmatic association between a label of a form input in our form with the actual input itself. And if we contrast that with the experience of a well marked up form, we will see that not only do forms show up in the elements list navigation or web rotor, but what's announced when interacting with these input fields is the labels that are associated with them and how this is done in the code. And there will be links to all of these examples, so you can play with things yourself and see like what's driving good and bad experiences respectively. So the labels for inputs are not only wrapped in label elements in HTML, but they've got this other attribute for, which is taking a name of an input, and then it's matching that with the name. Yeah, so it's taking a for attribute on the label whose value equals the value used for the name attribute of the input element in the HTML. The input, or I beg your pardon, it's the, so it's pointing to, so it is also a name, but it's pointing to the name ID value. So you've got an input element, it's got an ID, and that value is used for the for attributes value of the sort of matching label. And that's what drives a good experience in forms. So now that we've kind of seen some just basic atomic examples of screen reader navigation and what kind of drives good and bad experiences, um, I'm going to share a more complicated example. Let me tweak my screen share so that I can also include audio here. Share audio. Cool. Roberto, let me know if this doesn't work. It took 2 tries when testing it out prior. All right. So we are going to, we've got our Chrome window open, and I've already got my screen reader turned on. So, oh, and then, yeah, just quick context for what this screen reader test is going for. The goal is to go to adidas.com and try and locate a pair of shoes to buy, just random pair of shoes, specific size, and see if that's achievable using only a screen reader, basically if their website is accessible or not. But yeah, the little box that appears is from the screen reader, and that's also where the audio will be coming from. All right, so we're going to, we've got our Chrome window open, and I've already got my screen reader turned on. So going to navigate to just adidas.com. Cool. And then I'm just going to use the tab key to start with to go through the first couple focusable elements on the page. Usually that's where like a search bar is up in the navigation or something. Cool. So found a search box. I'm going to type in what we're looking for. Blue weightlifting shoes, and put men's blue weightlifting shoes. Cool. And submit that. And so it did find some blue. Yep, blue Adidas Powerlift weightlifting shoes. So from here, let's see if we can. So using a screen reader, I was able to navigate from the homepage of adidas.com to a search box, type in the text I was looking for, and then arrive at a relevant page. So then I tried to actually navigate on the page to select a shoe size and then try to add it to a cart for purchasing.
Hey, Joey?
Yeah.
Are you sharing your screen? Or is that a glitch?
I am, but I did hear a Jitsi sound effect a minute ago. That something might have happened. Let me try to restart it. Chrome tab. Can you see it again?
Got the screen.
Cool.
There's no audio.
Yeah, let me try to play it and let me know if it's 9.5. Can you hear the audio? So a lot of elements on a page. So typically screen reader users when navigating around will rely on quicker means of navigation, things like the web rotor to find like a section of content most relevant to what they're looking for. So I'm going to look for maybe like a heading that says maybe like shoe sizes or something. So a bunch of headings.
Yeah, it seems like the audio is.
Is it not sharing? It's obviously not. So all the talking, are you able to hear like any of the audio when the video is playing? Because that's not me talking live. Let's see. So, interesting. Yeah, it shows that Jitsi is trying to, or that it's sharing the tab. Let me.
You're good. You're good. Something's wrong on my side. You're good.
Yeah, Aiden was also saying in the chat that it wasn't working. Let me try one more time, and if that doesn't work, worst case scenario, people can dive into the recordings and stuff just on their own after the chat, and audio and everything is just kind of baked into those. So give one more try. Share Chrome tab with audio. All right. So yep, I was on adidas.com, basically used a screen reader to navigate to search, or rather a product page for men's weightlifting shoes, and then using the web router to try and navigate to select a size. Good page structure, that everything is the same heading level and sort of the same importance. And then finding that there's a lot of heading level 5s on the page for organizing things. Plus, they're not specific. It's basically just throwing like AdWords at me. All right, so headings isn't going to be a good way to navigate. Let's try maybe like a form, like a shoe size form section or something. We could try to find search box, found a button. A bunch of buttons. These are unlabeled buttons on the page, obviously not useful to us and trying to navigate around. No web spots. That's more of a browser thing than. Let's see if there are any landmarks on the page that can help us navigate around. Landmarks are things like section, main, nope, article aside. And last, we'll just try. No, so there's basically nothing. Page isn't structured in an organized fashion that allow us to navigate around by either form or kind of section. And so really our only last-ditch effort or option for trying to find what we're looking for, unfortunately, is using just tab navigation through all focusable elements on the page. So at this point, is a tester as a user, I pretty much gave up, as most users would, because basically if you can't navigate around using the elements list or web router of a page with hundreds of focusable elements, you're not going to press the tab key on your keyboard hundreds of times to navigate through focusable elements on a page to try and see if a shoe size of a shoe that you're looking at is in stock. Conclusion, adidas.com is not accessible, at least for this particular flow. In general, who's to say? All right, let's go back to slides and wrap up my presentation. Cool. So some takeaways from some demonstrations of screen reader usability testing. Remember that it's only one form of assistive technology, and so at best it is a proxy for testing accessibility of your application. Because it is non-visual form of assistive technology, it's not going to help you test visual accessibility concerns, things like color contrast, that text is sufficiently standing out from the background, or rather text color is sufficiently standing out from background color, that there aren't flashes on the page that could pose potential epileptic seizure risks, some things like that. Yeah, unfortunately, there's no silver bullets, although I will provide some resources to driving more accessible experiences in your software on the next slides. Very much like UX, it's just something where you try to continually iterate and get better rather than aim from perfect from the get-go, because who's to say what perfect is? It's always changing and evolving. But yeah, try and use components and semantic HTML, of course, when writing code, so that as you're solving problems, you only have to do so once and don't need to resolve them. And yeah, I mean, helping your customers benefits you, then you benefit your customers in helping them, and it's really kind of a virtuous cycle, or sort of like a positive flywheel or feedback loop, that helps yourself and your business. So some additional resources on the topic that can kind of help you in this process of making your applications more accessible are a lot of static testing tools, a lot of really great NPM packages. That's what all of these guys are. Everything from Eslint plugins to some like runtime accessibility checks. And you don't have to rush to write all these things down. I'll share the slides in the chat, and links to all of the videos and resources and everything afterwards. But then some great testing frameworks that also help to make sure that you're building accessible experiences. And then also some really nice UI frameworks that help just pretty much out of the box create accessible experiences. And I will post the link in the chat, but here's my GitHub. Here's where all of these resources are posted. And thank you, everybody, for listening in.
Yeah, that was awesome, Joey. Thanks for that.
Yeah.
If any of our members have any questions, just see if you can post them in the chat. But just to start off, from your screen reader tool set, if I'm using a Linux machine, is that tool set available there? Is there a particular tool set I should set up compared to a OS X, compared to like a Windows?
Yeah, and I can touch up the slides so they help address this a little bit more clearly. But Macs are definitely the easiest because they have this screen reader called VoiceOver built in at the operating system level, so you don't have to do anything. Maybe tweak some settings to make it a little bit easier to use and a better experience while you're using it. But other than that, it's just built in. On Linux, there's nothing that I'm aware of built into the operating system to help you with screen reader testing. There is, I imagine, open source software that you can turn to, which I'll investigate for Linux. I'm not sure of anything off the top of my head. For Windows, there's some really great free open source software called NVDA. I think it stands for like non-visual device accessibility, or that's probably wrong. But yeah, that's a most commonly used, I think, screen reader in the world. And that's, again, on Windows, NVDA. And JAWS is also popular, but it's paid for. And so unless you need like maybe a slightly better experience, then NVDA is like a regular screen reader user. Probably don't need to upgrade from NVDA. But yeah, I'll share all of this along with the slides.
Cool. Thank you.
Yeah.
All right. Well, yeah, if there's more questions, let me jump into the second part of our presentation. Let me share my screen real quick. Oops. Right. Hopefully that's seeable. I know I usually have issues with my laptop. Can you see that, Joey? Can you see my screen sharing?
Yeah, you're solid.
Okay. Thank you. So all right, so for the second part, so last month I did a presentation on, all the tool set, all the technologies that come about to make a React application. And this is before you start writing any React code, right? This is more or less the connecting, the dots, the technological dots, I suppose. So just quickly, what we did last month was connecting React with TypeScript, with Eslint, with Babel, with Webpack, right? So we took all these technologies and we wrapped them together in a nice little bow that Webpack provides so that we can get running, working local development, so that we can, learn more about these technologies, have a little playground. We can play with these technologies and most importantly, learn from these technologies. And so in this part, I'm going to do the next step, which is how do you get the JavaScript or TypeScript to play with the CSS? So last month, there's this mental model that I shared. And when you're thinking about it, React.js is kind of like the library that we want to use, framework we want to use. And we're going to have to wrap that with TypeScript. And because we're wrapping in TypeScript provides out of the box a certain configuration that we're just not going to use. And the main one is we don't care that TypeScript allows us to compile to JavaScript. We don't care about that. What we want to use TypeScript is for the type checking of our code. We're going to use Babel to compile down our JavaScript. We're going to feed Babel a certain configuration and our browser's versions that we want to support. And we're just going to let Babel take our TypeScript and compile it to JavaScript, compatible to the browsers that we give it. And then as we program, we're going to use the Eslint to give us, a better kind of just rules of how we should set up and write our code. And that also wraps into the TypeScript. And all that kind of connects into the Webpack. We talked about the hooks, the loaders, the module loaders. And at the end of the day, we wanted to spit out JavaScript. And so that's what we got set up last month. So again, just quick overview, the role and responsibility of each tech, how the tech components talk to each other, how they come together with Webpack. And the most important is that we can have a working setup, development setup. Again, it's not React specific. You could probably use the same setup with a different library. Vue comes to mind, or even Angular. You would just have to use the appropriate loaders for them. Other than that, the kind of like the mental model is pretty much the same. Quick updates from the previous. I changed, like I mentioned earlier today, the structure of the application is changing. Trying to figure out what's the best way to, not necessarily to scale out and to build whatnot. That's not the goal here. The goal here is to communicate, to share some knowledge, to learn about the components, what goes into making an application. And so I kind of changed the names because we're making a website from source to pages, right? So pages becomes our main directory. There is a lot of stuff with Webpack that I split out because it is a little bit complicated. And this has to do with like the paths associated with them. And also in a later presentation, I will build out a kind of command line tool that you can just specify paths. And so the update here is that I split up the path to their specific files, which I'll share in a bit to kind of drill that down. And then also I moved the browser list into package.json. And that essentially kind of signals that if you read through the package.json of this project, the package JSON kind of signals to anybody, to all the readers out there, that this application is only going to support what's on the browser list. There's no need to take a deep dive into the Babel configuration to figure that out, or the TS configuration to figure that out, or the PostCSS configuration to figure that out, right? I just surface it in the package JSON. But that's pretty much it. So if you go to the web page, there is the project. The branch that we're going to be using is CSS/PostCSS. Now I was going to go through another tool/library called Vanilla Extract, but I'll do that next time just because there's a lot to cover, and I really want to drill down what CSS Modules is all about, and how PostCSS gets us there. So if you go through the project directory, you're following along. This is kind of like the structure. I guess the README is pretty straightforward, right? There's a list of resources that go into making the CSS modules work with our application. At first glance, it might be overwhelming, but in the spirit of the Unix philosophy of keeping things single responsibilities, kind of methods and functionality, one method, one functionality to do a single purpose. Easily, there's other tools, other libraries out there that wrap multiple libraries that you see here into a single library. But like I said, this is more or less a teaching/learning/sharing, how everything kind of comes together to make a CSS integration into Webpack. And we'll go through these as well. So if you're following online, this is the repo. This is the branch that you want to be on. And again, if you clone it and you try to figure it out, you do npm install, npm start, and it doesn't work, just let me know, right? Open an issue, and then we'll get that fixed, so that everyone else can have access to it. So prior to, I guess, the next step, getting into CSS, right? Prior to the actual configuration of it, is trying to get an idea of what we're building. And so I'm going to go over kind of like a rough sketch of a website, of the meetup website that we're building here. We're going to talk about root configuration just really quickly, and importing files. Importing files is probably one of those nuances that it sounds easy, but it kind of gives you a bunch of edge cases that if you're not looking out for, it might bite you in the butt and leave you 4 hours, a couple days trying just debugging why your imports are not working. So I'll go through that as well. So back to the repo, I do have a website, PNG. If you're following along, just click on it, and this is just an idea of what the web page is gonna hopefully look like. It's not set in stone. It's just whatever. It's just there as a guide. We have a single page. We have these links on top. We have our GitHub repo, or GitLab repo. We have these sections that our users will be able to click on. We're gonna have these blurb. We're gonna have a subscribe to. If you want to partner up with the downtown meetup, you're a speaker, right? These are just ideas for this web page. Notice the colors, notice the logos, notice the SVGs, images, font sizes, so on and so forth. So this is kind of like the base. We're going to use this as our guide so that when we do the CSS, we can have something to play with. Here on the side is the root configuration, kind of like the project overview. Again, I have been going through this structure of how to structure a React application. It's not set in stone. I'm playing with it, trying to figure out what's a good way to share, to transfer knowledge, to learn. The kind of like the mindset I take is, if I'm a junior developer, how rapidly can I get up to speed with the application, with the web page, with the website, how easy or the difficulties involved in understanding components, headers, the pages, so on and so forth, right? So it's a work in progress. If you have any ideas, let me know. Again, on the GitLab, feel free to message there as well. So I do want to share like the root configuration, because this is, well, it's the root of it's the root of how Webpack is going to build our application. And I kind of split out this thing called root paths. So root paths is more or less where everything else, where all of our, I guess, components of our application live. So by components, I don't mean React component, I mean like, font components, images, the CSS files, where the scripts are, the TypeScripts, the TSX files as well. What files, what folders, what directories do these components live in? And so what root paths does is kind of aggregates them all for us and manages them for us. What root configuration does, it just imports those specific directories when needed. So they're not littered all over the configuration. They're just aggregated in a single root paths. They're all aliased, and they all can be tweaked. And this is the route I went with because, as I mentioned in a later talk, I want to create a command line tool that you can just specify the paths. And by breaking this into pieces like this, it makes it easier to target a CSS path in a certain file, in a certain directory, in a certain folder, and whatnot. Root configuration then splits up into two parts: local development, the dev config in the purple, and then the prod config in the pink. What this means is that the dev configuration is going to import what it needs from the root, and it's going to configure what it means to be like a local development. And what that entails is importing like a local dev server. And for production configuration, obviously we want to generate our assets. We want to generate our project files. We want to generate a build. We want to optimize. We want to minimize our code. We want to uglify it, so on and so forth. So it's very different configuration than what you want to do locally. Locally, we want fast iteration. We want want things quick. We want the auto hot reloading, so on and so forth. In prod, you don't need any of that stuff. So this is kind of like the mental model for root configuration. So I did mention importing files, and importing files is one of those gotchas that I wish we talked more about. It's not. It's a challenge just because the edge cases are many, and like I said, there's a lot of rabbit holes that one of us will go through and learn a lot, but I think it's unnecessary. So one thing before we start a project, and maybe you're just sitting down with your friend at a coffee shop, at a bar, and you're talking about importing files, because you're a fun guy and you just want to have these interesting conversations. There is a very opinionated, as much as Angular and React, opinionated ways of importing files. The one way that I've adopted, and I want to share my enthusiasm about it, is kind of just labeling these files, these relative imports, as aliases. So I have here, import header from @components, import, media queries from @styles, and @styles, @components, right? It can be whatever you want to create in your head. You can be a creative developer and use whatever name you want. But the whole point is that this @components, @styles encompasses what these relative imports, right? You substitute relative imports for these kind of components of your application, these things in your application that you're going to use, that you're going to mentally compartmentalize, And when you need like a CSS or something, instead of going dot dot slash dot dot slash dot dot styles, mentally you just say, hey, I need styles, and you import the style that you particularly need without trying to understand how far down deep you are in a particular folder or in a file, right? So you're importing a component, you don't have to memorize or keep track of what directory, what child parent relationship, what relative imports, right? You just call out the thing that you want to interact with. So in this case, add components header instead of dot dot slash dot dot slash dot dot slash so on and so forth. And this is good because as you develop, if you're a junior, if you develop, you stop thinking about these relevant imports. You stop tracking, right? You alleviate your mind in about thinking this of tracking where you're at in the folder or in the directory project. You focus into your application and your application components, your application things that the application needs and uses, so that you as a developer start building a mental model of the application in terms of the actual things that are being used to build it. And we're going to see a lot of that stuff in a little bit here. But if that's the route that you take, there's a configuration update you got to do, which is in Webpack, you got to configure aliases, and also in tsconfig, right? Because we're importing CSS files inside TypeScript configurations. So just quickly, let me go through the code base, the actual code base. Again, if you're in the project directory, feel free to follow along. But I'm just gonna this panel here is I have a little lag. Is my root config. So on the left here, I'm importing, I guess I should go through the root paths. So that root path, right? It's a simple JavaScript file that breaks up all the paths that are associated with pretty much everything that your application needs, the CSS, the fonts. Here we're going to use aliases as well, the images, right? Where they live and what files and what directories do they live in. And so it's a straight up just a JavaScript object that takes in the source directory, all the paths associated for Webpack configuration. And it's all aggregated here. The font path, image path. And so if you dig deep into these separate files, it's very straightforward, right? They're just returning an object that are, associated with arrays. It's just a list of strings of where certain, in this case, CSS paths lives, right? Where does Webpack need to look for to compile or to interpret CSS? And so these are the kind of like directories where I will feed Webpack where to look for when it comes to CSS. For images, the same thing. I have to tell Webpack what paths my images live in. And then I add a favicon here. And also another thing too is where you want to output your stuff. And so Webpack needs to know like where it's located and how you want it to build, where you want it to build. And so root path kind of like splits that up. And so the way of thinking about it is that you have a lot of these locations, right? And it's very flexible. Nothing is set in stone. I'm still playing around with it, but just give you an idea that it's very flexible. You can throw in your own directories that you want to give Webpack so they can learn, so you can see what works best for you. The aliases is what we were talking about, how you want to import. Now, I broke these down to assets, aliases, project aliases, and component aliases. And components is a very overloaded Word. So in the component section, I have at components, which is what I define kind of like my shared components. Elemental, don't worry about that. Again, it's just experimenting with naming, right? How I want to import. The trade-off here, instead of using dot dot slash dot dot slash, if I want to use logos, if I want to, wherever I'm at in my React.js code, all I have to do is import at logos, and then just extract the logo that I want to, right? I don't have to keep track of how far deep I am in the chain of directories to import that specific thing. And then on top of this, it gives you a good way to communicate with other developers. I'm at routes, at services, at store, right? We talk about these components, images, styles, fonts. The more we can name our things that we're working with, it's a better way to communicate and help also debug. So that's the aliases, that's the root directory. And this all kind of falls into the Webpack. And so we have our dev config, which we covered last time, and then we have our prod config. So let me just switch over here. So our root config kind of brings the reusable code of what both our configurations are going to use. And like we covered last time, the TypeScript goes here. We have our plugins, HTML plugin, the fork check for TypeScript, the Eslint plugin. We have optimizations, we have performances. And this is where we kind of feed in our aliases. This is where we tell React, hey, React, hey, Webpack, we're going to use at components, at reducers, at APIs, at whatever. Here's where the aliases live, right? This is where we register them all into Webpack. Now in TypeScript, we also got to do that. And so you can see here at TypeScript, because we will be importing CSS into our TypeScript. At the same time, we want to use TypeScript, the type checking, right, to give us what's inside at pages, at lib, at logos, right? We want those kind of hints. And so the TypeScript configuration, by adding these paths into it, kind of signals TypeScript as we develop to extract that kind of static knowledge. And as we type in at components, it will give us a list of what components we can import. Right? Again, it's all about not using relative paths. It's being very specific about a certain thing in our application that we want to explicitly use. So before we get into the CSS module, Webpack 5 specifically really adds into, it kind of like updates these loaders that we kind of explicitly had to use before that. And so like, imagine using fonts and images. You would have to use like the file loader, the URL loader, and the raw loader previously. In Webpack 5 by default now has it built in kind of like an asset management. And they have on their web page, asset modules that goes through this new built-in system. So we don't have to use any specific loader. We don't have to install any new library or package. With Webpack 5, we just add these kind of types. What types of assets are we doing? What types of assets are we looking for? And how should they be exported? Now, in our example, we're using fonts and images. And so Webpack 5 exposes asset/resource/inline/source, and then asset. And they all have different responsibilities. They all do different things. In our code base, in our configuration, we're going to import images. And we're going to use a type resource. And type resource is telling Webpack to export a separate file for these images, like the logo or the React logo. Right? They're more than a few kilobytes. if you're using PNGs, which we are. And we give it a specific, we got to tell Webpack where to output it. The same thing with fonts. Before you would have to npm install, I think, a file loader or something. Now it's built in type asset. Now type asset here, it gives Webpack the choice. If it detects a, for example, SVG that is less than this max size, it's going to inline the SVG, like a URI. If not, it's going to generate a separate file with that asset inside of it. And if it separates a separate file, it's going to dump that file into this output. So mostly we're using it for our fonts. And so that shouldn't be there. So with those two asset modifiers, we're pretty much done, right? From here on out, Webpack will know what to do with our images and our fonts. And so that's kind of like the new additions to the Webpack configuration. There's really no changes to the dev server or the dev config or the product config when it comes to anything else that's outside of CSS. Now, to get into the CSS modules specifically, we're going to quickly overview why CSS modules, the what, the how, and the why of CSS modules, right? Sorry, we're going to talk about the problems of CSS and then go into the what, the how, and the why of CSS modules. So if you've been following along with like the history of CSS, the tons of tooling out there, conventions, this pretty much sums it up. So at scale, there's a lot of problems with CSS, cascading, right? Cascading style sheets. So global namespaces, dependencies, dead code limitation, you know, it goes on and on and on. But essentially, very talented developers have come to the same conclusion that, you know, CSS by itself is it's a foot gun. And it has a lot of things that you have to keep in your head as you program that, you know, maybe not one or two, a whole team of developers need to do. What can we do? And so that's where CSS module comes in. So what is CSS modules? A CSS module is a CSS file in which all class names and animation names are scoped locally by default, right? If you go to their GitHub, it's straight up from their web page, from that page, from the README. And the key here is that the names are locally scoped, right? That's kind of like the key here. So there's no more global by default. Everything's kind of scoped locally. It's not an official spec, so keep that in mind. It's just, you know, probably more convention than anything. But it is implemented by Webpack and other build tools as a build step, right? So go ahead and write CSS as you always have. Don't change that. But the way that it's built and the way it's developed and deployed, Webpack will implement it as a CSS module, right? Scoped. So how they do that? So basically in the classes, right? The classes are dynamically generated, they're unique, and they're mapped to the correct styles, right? Again, scoped classes. And so how are they done this way? Well, Webpack does it for us, and we'll go through that. So why should we do this? Why CSS module? Because not only does it eliminate a lot of these problems at scale, right? It also, as a developer, it puts all the styles in a single component in a single place. And it also makes it so the styles only, right, apply to that component that's using those styles. So there's no duplication. The styles, you can reuse names, as you'll see in a bit, for every component, and have the Webpack generate unique names for those components, Now, there's a lot about CSS that's CSS modules, to be specific, that you definitely need to. I recommend learning about it, why you need it, how to use it, gotchas. There's a lot of good material out there. And again, it's something that just keep under your tool belt as a front end developer. So for us, right, taking that philosophy of what CSS module is, we wanted to do as a front end developers, right, as part of this part 2 is that we want to configure the CSS. But before that, we got to take a step back and think about like what are we looking for as a developer? What do we want? What kind of a developer experience are we looking for? And so, I mean, these are kind of like the baselines. If we can't configure this, then you know what? It's probably not to our advantage to even do it. So, as a baseline, we want to import CSS files, right, from TypeScript. Easy. We want to import CSS files from other CSS files. We want to write CSS with the kind of like the Sass syntax, right? Your mixins, your variables, your includes, so on and so forth. Another thing too is we don't want to worry about naming, right? We want naming to just be just there, but we don't have to worry about it, like naming collisions. And on top of that, we want to use a CSS module resolutions. As we develop our CSS files, and I want to import variables or I want to import fonts, if I want to import mixins, I don't want to care. I don't want to keep in mind, the // type of resolution, relative imports. I want to use a module resolution that kind of goes with what I just spoke about earlier, at syntax, at variables, at fonts, at styles, right? So I want my TypeScript files to use that type of importing, and I also want my CSS to do the same thing. So right before we get into it, the list of tools that we'll be using, right? PostCSS is the transforming of the styles. The PostCSS loader is the hook into Webpack. PostCSS preset env is taking the latest and greatest of CSS and adding polyfills to it depending on the browsers that we're targeting. Very similar to what Babel is doing, but we're going to use PostCSS preset env to do that for us. PostCSS pre-CSS, that allows us to write Sass-like markup, right? So if you enjoy your mixins, if you enjoy your variables, if you enjoy your includes, right, this easy transition is nothing. Imports, right? We want our CSS files to include other CSS files, but also like other, maybe you have a node module or something. And then for production usage, we want to extract that CSS into its own file. And so mini CSS extract plugin will do that for us. It also plays into something else that we'll cover later on about code splitting. And then to top it all off, at the very bottom here, we have a normalizer. A normalizer, you're right, makes it, hope everyone's using some kind of normalizer in their projects. Just lines up make sure all the browsers that you're targeting render the same. Right? It's normalized a preset of CSS. And types, I guess. Okay, so now that we got all that out of the way, how does all come together? So in development, we're going to use a rule. We're going to add this rule, CSS rule. And we're going to target kind of like where our CSS directives is. And that kind of comes from the root paths, right? We're going to pull out our CSS and we're going to pull out our post CSS configuration from our paths, and we're going to slap it into kind of one of those rules, module rules. So whenever Webpack encounters a .css file, Webpack knows what to do with it in the development environment. And so the two loaders that we're using in, well, I guess the three loaders that we're using in the development environment is style loader, the CSS loader, and the PostCSS loader. The style loader injects your CSS files or your CSS rule set into a style tag at the head of your HTML page. So what does that look like? Let's see if I have it here. No, I do not. So another thing I should mention is that this project is mobile first. So this is how I develop it. If you run it npm start locally in machine, this is kind of like the same output you should expect. It's again, it's not set in stone. There's a lot of work to be done, but just to give you an idea of where I'm going with it. So the style loader. Let me zoom in here. You see all these style tags? That's because the style loader is not creating a separate file for me, right? This is development environment. I just want something quick and easy. So it just injects the style of the CSS at the head. That's what style loader is doing for us. CSS loader. Now this is where like the CSS modules kind of come into play. So there's a lot going on here, but the crux of it is in this modules object, where the mode here means local, right? We're going to keep the CSS local to our components. Local identity names is how are we going to name our classes? Our classes, we're going to use regular, CSS classes. The names that we use in our CSS are going to be appended with a hash associated with it. How does that look like in the code base? If you look at my home layout, I have a class name called the home layout, and then I have this a 4-digit hash _ELJ, right? Look at my header, my copyright, my footer. If you look at my main, I have my sections, and again, the classes, layout, but every single one of them is unique. I'm using the same class name layout for every section, but Webpack is generating a different class name using the hash. Named export is how we want to export the CSS into the TypeScript. I'll show a use case in a bit. We want to use camel case only when we import into the TypeScript. Get local ident. So Webpack has a lot of these customizable kind of like helpers, where if something's not working for you, I'm pretty positive Webpack has a way to solve it for you. They're a little bit tricky, but in our case, and what I wanted to show this is that I have a class name named active somewhere in my code. I don't want Webpack to append a hash to it. So this tells Webpack to avoid it. And so if my component is a header and I have a class name active, well, I can come here into my components, find my header. I have a class name active somewhere around here. Let's see where it is. Active here, the CSS active. And I don't want Webpack to append a hash to it, right? And so I can configure that to say, you know what, ignore it and just give me the, just maintain the same name to it. I don't have to worry about cascading because it's a child inside a parent, and that parent is unique, right? The nav item will have a hash associated with it, and so that hash is associated with this .active. Maybe it's a little bit too much, but just let you know that Webpack does provide a lot of these hooks to solve a lot of these problems. And then at the end of the day, we wanted to import our PostCSS loader. So what is PostCSS doing? In our configuration folder, we have a PostCSS RC. And in here, this is pretty much it. This is kind of the golden goose here. We were telling Webpack, or we want to use the pre-CSS, right? We want to write our SAS syntax. We want to write not just our SAS syntax, but we also want to write the latest and greatest CSS. So compile it down. And then we also want to import CSS files within CSS files using the aliases. So kind of these three plugins come together. So in order for that aliases, right, at styles, at variables, whatever, we have to tell Webpack how to do it. If Webpack runs into a CSS file that has at styles associated with it, follow this logic here to find where to resolve that path. So that's kind of the configuration for development. Production is a lot easier, where it's just like, hey, you know what? I don't really care. Just squish it all together and export it. So the CSS loader is exactly the same. The only difference is that I'm not using the style loader. I'm not using the, I'm substituting the style loader for a mini if CSS extract, right? It's going to go through all my components to CSS, and it's going to extract them out into a different bundle, right? It's not going to go inside the JavaScript. It's going to go to its own file. And that's pretty much it. And that file name is going to follow this kind of like this naming scheme. So just to see the end result, if we go into our code, npm run build, just to give you an idea of what Webpack is doing with all that configuration, with this production configuration, it's going to export a _Webpack output directory, and inside that directory is our build. Ignore the warnings. These are like, it's telling us there's, our file is too big. Try using, extract or dynamic loading. Try to use minify, so on and so forth. That doesn't really concern us right now. So this is what happens, right? So Webpack generates all this stuff for us. Here's our HTML document that gets loaded. We see here in the bottom our JavaScript files, and here on top we see our favicon. The image gets injected, and also our single CSS file gets extracted. If we go into our CSS file, we see all the CSS of our project, and we see the CSS class names with the hash names. It's not minified, it's not uglified. In the production configuration, I turned off optimizations, minimize false. So that's just for, again, as a learning proposition, coming here and see how what Webpack is doing, right? Class names that are repeated over and over again, but just different hashes associated with them. I do want to show examples of the CSS quickly. So in our home, we have a hero. I guess prior to that, so our root page, our index.tsx at our root pages, we are using the React router. So, going back to the application, this navigation bar is going to use React routers. We see the URL changing. We see that if we click on one of these, I guess, links, that actually, you can see the hashtag in front of it. It takes it to that particular section. And so let me close this out, but we see the classes, we see the navigation. That's the header. The main section here is a hero. We have a div, we have a container. H2, we have the image. Again, the image is just injected by by Webpack, and then we have our list, right? So how does that look in the code? So this is where it is ingested initially. It's just the React router wraps around our components, our paths. Here, because we're using a TSX, I am importing a CSS directly into it, right? So that PostCSS loader import is going to take care of us. At styles, again, instead of using relative imports, is just at styles is the idea of where our CSS lives. I have normalizer, I have a global CSS, and I have fonts. Again, Webpack knows what to do with these files inside our TSX. Our TXS, instead of using, again, relative imports, I'm just using at components, right? Again, the concept is I'm using things that my application is being built on, and I'm pulling those things out, and I'm kind of combining them together instead of using relative imports. The only time I use relative imports is when it's in the same directory. So that's kind of the idea here. So let's just go and see what the home directly kind of looks like. So the home has the sections, has the layouts, again, home layout, kind of like the main tag. And so just quickly go over the hero section. So I'm importing my style. They're camel case. I guess frag atom is camel case. If I look at my styles sheet, styles.css, in my CSS, I'm importing other CSS, right, at import. And I'm using the same, alias at styles. And at style lives in my assets. And so in this case, just to give an example, I'm looking at my fonts, right, at font face, and I'm throwing in some kind of like Sass syntax at mixin and extend. And again, that pre-CSS is going to help interpolate that into regular CSS. I got my variables, right? Colors, background, colors. I have layout variables as well. Either way, in my CSS, I can directly import those particular CSS types, media queries, variables, without using the relative imports. So just really want to drill this home, right? Whatever it is that you can possibly do to remember stuff like that. Great, the IDE is great for doing that. But I think at styles shows intent. It shows exactly what you're trying to do and the different types of stuff. By itself, the CSS loader is going to take these names and export them for you to such an extent that all you have to do is treat it like it's a regular, ES6 import module. And to use it, right, you just litter it inside your class, inside your JSX. So I've got the layout as part of the class name, fragment, frag atoms, so on and so forth. So all the other ones follow a very similar pattern. You import the CSS that you need, and then you start using it, right? Include mobile layout, use a variable. And so that kind of fulfills the pragmatic configuration criteria that we wanted. Now I can build a React application, a full-fledged React application with CSS. With the CSS out of the way, with the CSS married with the JS and HTML via the JSX, I am ready to build a full-fledged application with all the CSS, all the animations, all the images, SVGs, and what have you. I think the logos I have kind of, again, just importing at images. Again, another example of the aliases. They don't have to be CSS files, right? It could be PNG files. .jpeg files, right? Webpack knows what to do with it once it runs into this file and injects the logo path, so on and so forth. So, and again, check it out. Check out the website. Check out the repo. Any ideas, let me know. But the CSS is integrated with it. And this is a lot, right? PostCSS, understanding PostCSS comes with a lot of overhead. The next time I do this, I'm going to be using just one library called Vanilla Extract. And you'll see that you can pretty much get all the same functionality without a .css file, but maintain all the benefits of the CSS module. So that's kind of it, what I have for today. If there's any questions, let me know. I think there was a lot to cover. Let's see, just gonna go over it real quick. Okay. So if there's not any questions, that kind of concludes the meetup for today. Thank you for everyone joining. Thanks, Joey, for your presentation. The screen reader stuff is, again, extremely important for developers. And thank you for sharing that knowledge to us. I know I think I mentioned it to you, part of the website, the meetup website, I want to integrate all that good stuff of accessibility. So definitely be using a lot of your topic points, and also Aiden in his accessibility presentations as well. So that being said, if there's no other questions, I guess it's time to say goodbye. And I hope I see everyone next month. We do have our presentations for next month, so please feel free to check it out. And a big shout out to Aiden for helping organize the presentations. All right, everyone stay safe. Talk to everyone later.